This is a YouTube video lecture on Chapter 16. This section is on esters. As is indicated, esters are formed between a carboxylic acid and an alcohol. In this case, the carboxylic acid is ethanoic acid. In combination with the alcohol methanol, we form methyl ethanoate. This is an esterification chemical process based on the word ester formation. In this example, we see once again ethanoic acid in combination with methanol in the presence of an acid like HCl, and heat forms the ester methyl ethanoate plus water. This reaction is reversible. That is to say, the ester in the presence of acid and heat can break down into the carboxylic acid, ethanoic acid, and methanol. So in this case, we have both the forward and reverse reaction, both of which are catalyzed by an acid such as HCl and heat. In this specific example, we see the formation of an ester called propyl ethanoate, which is the result of a condensation or esterification reaction between ethanoic acid and 1-propanol to form the ester product propyl ethanoate. Again, this reaction is reversible. That is to say, the catalyst H+, as in the case of HCl, hydrochloric acid, and heat can either result in the formation of the ester or its breakdown into a carboxylic acid and 1-propanol. In this example, we see the relationship between salicylic acid and acetic acid. Salicylic acid contains the OH functionality phenol, which can act as an alcohol and condense with acetic acid to form acetyl salicylic acid or aspirin. We carried out a similar reaction in the lab in which salicylic acid was combined with acetic anhydride to form aspirin. In this particular case, we notice that in the presence of an acid plus heat, the reaction is reversible. That is to say that aspirin under these conditions can return to break down starting materials, salicylate or salicylic acid and acetic acid. That's why in the question about the extended shelf life of aspirin, why does it sometimes smell like vinegar? It smells like vinegar because of the breakdown reaction to form acetic acid, which is the smell of vinegar. In the case of salicylate, we can also use the carboxylic acid functionality of salicylate in combination of methyl alcohol to form the product methyl salicylate. In this case, the acid and an alcohol combine to form the ester. This product, methyl salicylate, is oil of wintergreen, or the smell of oil of wintergreen. In naming esters, it's important to realize that esters are a combination of a carboxylic acid, the carboxylate group, and from an alcohol, the alkyl group. In this case, the IUPAC name, ethanoic acid in combination with methanol, forms the ester name methyl ethanoate. Several common esters that we come across are ethyl ethanoate, methyl propionate, and ethyl benzoate. Some common esters that are found in fruits. Esters provide a fruity flavor or smell to many kinds of food products. For example, propyl ethanoate is the smell of pears. Pentyl ethanoate is the smell of bananas. Octyl ethanoate is the smell of oranges. Ethyl butanoate is the smell of pineapples. And pentyl butanoate is the smell of apricots. In the naming of esters, as in the case of this structure, by IUPAC, we first identify the longest chain that is originated from an alcohol. In this case, we know the longest alkyl chain is a propyl group. We then identify the group that has the parent name of a carboxylic acid. In this case, the parent name is propanoate, and so the name of this ester becomes propyl propanoate. Propyl comes from propyl alcohol, and propanoate comes from the carboxylic acid propionic acid. So this is propyl propanoate. Here we learn about the properties of esters. In this case, we're comparing 4 hydrocarbons, that being butane, methyl methanoate, 1-propanol, and ethanoic acid. All 4 of these compounds have similar molecular masses, and so we've eliminated molar mass as a factor in determining the boiling point of these compounds. In this case, we find that in the case of the alkane, it has a relatively low boiling point at 0 degrees centigrade. We know this is the case previously because there is no hydrogen bonding in this molecule. In the case of the alcohol and the carboxylic acid, they have significant hydrogen bonding because they are polar molecules with partial positive and partial negative polarity charges. Their boiling points, as a result, are relatively high, 97 degrees centigrade in the case of the alcohol and 118 degrees centigrade in the case of the carboxylic acid. When combined, when carboxylic acids and alcohols are combined, we form the ester. In this case, the ester has a relatively low boiling point, even though it has the same molecular weight as the alcohol and the carboxylic acid. That is, its boiling point is 30 degrees centigrade. We know that esters do have the ability of forming hydrogen bonds because they still contain some polarity, but not the same level of polarity as the carboxylic acid and the alcohol. As such, they have a lower solubility in water. Esters up to 5 carbons are soluble in water. Anything higher than 5 carbons is either partially soluble or insoluble in water. This is because of some hydrogen bonds that are formed. Now, in terms of reactions of esters, we know that we can carry out hydrolysis, and more specifically an acid hydrolysis of esters, in that when, for example, methyl ethanoate in the presence of water and acids such as HCl and heat will degrade into ethanoic acid and the alcohol methanol. This reaction is reversible, and that is to say ethanol ethanoic acid and methanol can combine in the presence of acid and heat to form the ester. So this is a reversible reaction. In a similar fashion, we can also carry out base hydrolysis of esters. This is called saponification. So, for example, an ester such as methyl ethanoate in the presence of the base sodium hydroxide with heat will hydrolyze to give back the carboxylic acid as a sodium salt. In this case, we have sodium ethanoate. In addition, the byproduct of this reaction is methanol. So methyl ethanoate in the presence of sodium hydroxide will break down. This reaction is not reversible, but will break down to form sodium ethanoate and methanol. This reaction is a base hydrolysis of esters known as saponification.